You can start.
Okay, so good evening, everybody. I'm still your host, Afolabi, and today we'll be moving to our next section in next section in our curriculum, which is working with LCDs, which are liquid crystal displays. Okay, so first things first, I'd like to ask a few questions. Just do a quick recap on the last class we had. So I know that you guys really understood what I actually taught, and if it's going to be okay for me to move on to the next topic. So who here can just give a summary of what we discussed in the last class? Anyone? There's no wrong answer here. So okay, say someone answering. Talked about for and while loops. Yes. So what are the other things we discussed? Any other person? Because I know that's not the only thing we discussed last week. Anyone? Before I start calling names, I don't want to call names, but uh, just want to make sure we all understood what we talked about, because I don't see a reason to continue if we can't really understand what is being taught in class. So
So is it that in the space of 1 week, everybody has forgotten what we learned last week, or you guys didn't go back to practice, or because you guys wrote the exam, you did not go back to it? Because I don't think, I mean, it's practical, so I don't think it is something that you guys should easily forget. And it's only Diamond that is giving answers to the questions. Are we wasting our time? Chinedu, Israel, Diamond, I'm not getting any response. Are we audible? Are we together? Can you guys hear us? Is there a reason why
Yes.
you're being silent? Israel and Chinedu, are you here? Yes, I'm here. Okay. Please, what did we learn in the last class? Just type, just typing is fine.
okay, so if we're not going to get any response, think that I'll just consider the class. Maybe I can do a touch up on what we discussed in the last class, in case we've all forgotten. So, but in the meantime, let's go to what we're going to be discussing today. So, uh, first problem statement I have is what are LCDs and how are they important to embedded systems? So LCD, sorry, LCD stands for liquid crystal display. So I'm sure we've all been taught what an LCD is from childhood during computer science classes. But I want to go deeper than what we've been taught in computer science. So LCD, they are kind of displays you see everywhere. Then calculators, they're the ones in microwaves, they're the ones in car dashboards, even though some of them are getting changed. Where the old phones, especially those Nokia phones, all those old phones, that those are the displays you see in those devices, and they are perfect for Arduino projects because they are cheap, they're easy to read, and require very low power, very little power to actually use. So the display we're going to be using today is a 16:2 display. It's a 16:2 display, and it's an I think I2C display. So what a 16:2 display means is, okay, it means that it can display 16 characters across and and 2 rows down. So that's a total of 32 character combinations. So now, how does LCD work? So LCD are made up of liquid crystals. So liquid crystals are materials that flow like liquid but have molecules arranged in a pattern like crystal shell. So when you apply electricity, these molecules rotate and either block light or let it through. So come on, I want to see if I can get pictures for liquid crystals. Okay. Okay. So while I'm trying to get a picture. So now, when those molecules rotate and they block light or let light through, what happens is, by controlling which segment of the crystals get electricity, you can form letters and numbers. Thus, you can control what part. So now each character position on the LCD is made up of 5x8 grids of pixels. So which means by turning on different combinations of these 40 pixels, you can display any character, which includes letters, numbers, and symbols. So now, the problem with the basic LCD displays is they usually have 16 pins. So that's the original LCD displays. So now imagine having to connect 16 pins from your Arduino, so the LCD. So it's just where the I2C comes in. So I'm going to share my screen very soon. I just want to give a total rundown of what's going to be happening so that by the time I share my screen, it's not going to be so overwhelming. So now, I2C means inter-integrated circuit. So what it is an IIC is an adapter that connects this is an adapter that makes connect all the that convert all those 16 pins from your original LCD to just 4 pins. That's the VCC as the 5V power, the GND, which is the ground pin, the SDA, which is the data line, and SCL, which is the clock line. So one example I can give is, you can think of the I2C as like a postal system, that postal system used to send letter. So instead of having a separate wire for each piece of information, each piece of letter, you have one wire, which is the SDA, that carries all the messages. So in our post office example, the SDA is going to be the postman. So the postman carries all the wires, and the SCL, which is the second wire, which is the clock wire, keeps everyone synchronized on when to read the messages. That's okay. When the postman delivers this letter, this is when you should read your own. This is when you should read your own, and other things like that. So the I2C adapter always have two addresses, which is either the 0x27 or the 0x3f. So those are like street addresses. So the Arduino knows which device it needs to talk to, or which device is talking to when multiple I2C devices are connected. So any questions on that? Any questions before continue?
I was not really hearing you clearly.
Okay. So I'm going to repeat myself. So what I spoke about earlier was discussing what LCD is and what an I2C LCD is. So when I talked about LCD, I talked about liquid crystals and what liquid crystals are. So liquid crystals are liquid, like liquid crystals are these materials that flow like liquid, but they have molecules arranged in patterns, in pattern like crystals. So okay, let's say example, I don't want to use water as an example, but think of liquid crystals as water that has lots of stones in it. So the stones are the molecules that have crystal-like patterns that can be different shapes or forms. So now, the way the molecules, the way the stones can be arranged is when you apply electricity to it. So when you apply electricity to the water, those stones, they can either rotate. So no, those stones rotate. So they rotate, and they can either block light or let light pass through. You get, that's the way they are arranged. So let's say you have water on a slab now. So let's say the stones are in the water. If you run electricity through it, the way electricity makes those stones rotate, it's still inside the water, but the rotation happens, and the way the rotation happens is the molecules get rearranged in a way that they can either let light pass through the water to the concrete slab, or block the light from reaching the concrete slab completely by just getting arranged in a way like that. So now the way LCD now gets to use that is by controlling what part of the water, or by controlling what part of the stones get electricity. You can arrange those stones to form letters and numbers. So now each character position of the LCD is made up of 5x8 grids, meaning by turning it on, you have a different combinations of 40 pixels. No, 5 times 8 is 40. So which means that you can display any character, which includes letters, numbers, or symbols. So before that, I also mentioned that an LCD, most LCDs, or the one we're going to be using today, is a 16x2 display, meaning it can display 16 characters across 2 rows down. That's 2 rows, but the first row is 16 characters across. That's 16 columns. That's
Sorry, Okulabi, can we see pictures of what
okay.
you're explaining?
Yes, I'm going to get that now. So let me share my screen. I've not really developed a circuit for today's class. I was busy, but let me just do this.
It's fine, like you can just do it and then we'll follow you.
So
Yes,
you can also see my screen, right?
yes, we can.
Okay, so now this is our LCD, right? Just want to zoom it in. Okay, so this is an LCD. Now, as I mentioned before, the LCD, let me check it. let me delete this one that I'm doing right here so that we'll be able to get the LCD to work. So you understand what I mean? Okay, comment tutorial. Okay, LCD, a liquid crystal display, right? So what I mentioned before was that it was 16 by 2, meaning you can have 16 characters across this line, the first row. I don't know if you guys can see my mouse. I should be able to a marker. I should be able to use comment first. So I didn't see the question earlier, but I'm going to answer it. So I can't really get a marker, so and I don't know if you guys can. Can you see my mouse movement? Okay. So now I think Israel's question. Okay, Israel, you can see my mouse. Can you see it now? Okay. So to answer Israel's question, the ISC on a normal day, you see this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these are the 16 pins that you connect to your Arduino if you're working with a traditional LCD, that's every normal LCD. But with the advent of I2C, that's the so what was it again? Yeah, I think I've forgotten the minute. I think inter-integrated circuit. So with the advent of the inter-integrated circuit, we have these 4 connections, which is ground, power, VCC, SDA, and SCO. Now, these 4 pins are integrated inside any LCD that has an I2C connection in it. So you don't need to like bring another artificial connection or component again. It's integrated. So, but for the gurus that don't want to use the I2C, they're still free to use all 16 pins. So that it's not going to be with this LCD because this one is I2C LCD. So all these are getting translated into this. So these are the I2C communication protocols that most Arduino LCD uses. Okay. So now I want to move to what I'll say. So this row can take 16 characters. Let me turn on there. Sorry, I want to turn on there. Okay. Now, if let me check. I think I should be able to. I'm trying to backlight one delay for. So I want to show you something. Okay. So now you can see 16 rows 1, 2, 3, 4, 5, 6, 7, 8. Sorry, 16 characters across. 8, 9, 10, 11, 12, 13, 16, right? This 16 characters across, then 2 rows. So if you can, let me zoom in. Let me zoom in. So, sorry. So I think I zoomed it too much. I want to show you something. Okay, so with our LCD, you can see that each of these are like a crystal, as I explained before. So this It's letting light pass through it. That's why you can get a pixel. This is not letting light pass through it. That's why it's dark. So each, as electricity passes through it, each of the molecules, crystal-like molecules, are getting rearranged in a way that either let light pass through it in form of this, or light not passing through it in form of this. You all understand that? Or shall I re-explain? Okay, so now this rearrangement, I also mentioned something about 40 pixels. That's 5 by 8. That's what each section has. If you also count this, see, you can count 1, 2, 3, 4, 5. Then you can count 1, 2, 3, 4, 5, 6, 7, 8. You can always count 8. That's 40 pixels each, as I explained earlier. So each of the section is 40 pixels. That means you can form any character, including symbols and letters and numbers, as this is showing. Any questions so far?
Nope.
Okay, if there are no questions, then so we'll move to the next. That's oh, I think I used it. Okay, so I'll be moving to the next thing. How to wire this piece of tech right here. So now wiring LCD, especially an iOS2, is very complicated if you're doing it for the first time, because there are some bugs that you will encounter. First things first, we want to talk about the normal ones that we already know. That is the ground. That's this GND. We know that that's ground. We know power is VCC, and that connects to a 5-volt line. Then the SCL and the SDA. So I'm going to be very honest with you. I don't know how this one works, because these are connected to this part of digital. I don't know if it's part of the digital or something like that. So I was rushing. So the one I was trying to create, the SDA was going to go to A4, then the SCL is going to go to A5. So what I was going to do was I was going to connect it along with the ultrasonic sensor we used last week to display what do you call it? To display this thing. What do you call this thing? To display the distance measured and other things like that. So now I explained what the SDA and the SCL is, but since they are I should recap. I think I have to explain what that is again. So the SDA is the data line, as that's the connection that the information that's LCD is trying to transmit. That's where the information just passes through. So that's where the pass through the SDA. And the SCL is so looking gibberish. So that's why the clock line is there. So the clock is telling that, okay, pixel A should move at this time, pixel B should move at this time. You get my point, right? So that's the SDA and the SCL. So now, as I explained to you before, the way the LCD connects to your data line is, when I mean data line, I mean the way all these 4 pins connect to all these several pins we have. Is I don't know if I don't know the way I'm going to explain it. I want to say is depending on the way you want to program it. So, for example, now let's check the code for this default. This one is a default one that is here. So you can see this let's see. Is there anybody here that does not understand C++ code before I start? Is there anybody here that does not understand C++ code? Let's see. Okay, so it seems like everybody understands C++ code. So now, for this is not the original code I add and stuff for every project. So this is what I add because I was going to add the what do you call it? The this thing, the ultrasonic sensor to the what do you call it, to the project. But now, first of all, this thing, what will I call it now? This LCD is connected to this pin, this pin that doesn't have a name, and this one that doesn't have a name. So those are what would I call those pins now? They are default points that you can map to anything on your code. Not really anything, but those are points that you can map on your Arduino when you're writing your code. Most of the things that you're going to be working with, if you've done the connection, is going to be done on your code. So now, the way I wrote my code was we're going to map the SDA to analog pin 4 and the SCL to analog pin 5. So what we're not going to do was we're going to initiate the LCD, then we're going to measure distance. So we're going to do the normal measurement of the distance. We're going to do the same code that we wrote for the ultrasonic sensor. It's the same thing we do. But for the LCD, we first do initialize the LCD, but write the same code for the ultrasonic sensor. What we'll now do is, so we'll now put the result in our display. Put it in our display and let the LCD display it.
I'm so sorry. So I want to say that I hope we are all following that. It's not that Afolabi is just presenting, I'll be sharing his screen with us, but we're actually like applying the practical and practicing it as we are following the class, because I honestly believe that is the reason why a lot of us are forgetting what we learned. Like this time next week now, if we ask me, I don't want a situation where one thing led to the other and then nobody can tell us what I hope that as he's doing it on Tinkercad, we're also doing it with him, because there's really, I don't want to say there's no point, but more or less there's no point in you attending the class and you're not following the practical and you're just listening. So I hope we're all following. Please, if you are not, please just adjust. And if you can't, please make sure you practice before today ends, because we still have another class tomorrow. So let's not be, for lack, as harsh as this sounds, let's not just waste each other's time. Thank you. So Afolabi, you can continue. Sure. That's just what I wanted to say.
Okay, so now our results gets printed to the display, then the normal if statement I taught last week. So that's if the distance is less than 10, you print this. If it's less than 30, you print this. And if it's more than 30, that's in this case, that's why the else is there. You print 0, and that is like that. If you can see, there's no, I don't think there's a loop here. Yes, there's no loop in my code. But there's a loop in the default code that came with the pre-built connection that I'm using here. So what I would like to do now is I would like to start the original one that I was going to present in the class. But the only issue I have is, since our class is 1 hour, we won't be able to complete it in time for our class. So part of the curriculum, if you guys check it out, there was supposed to be an assignment this week. So maybe what I'll do is I'll just explain more on liquid crystal display. So I will give you an assignment. You guys will create the or you add this plus the ultrasonic sensor. So as to not stress you, I will give you the code to run. So you will put the code in this place, then you run. If your connection is working correctly, it's going to run. And if your connection is not correct, it's not going to run. If start clear with everybody. Is that something we can all do? Okay, all right then. So because this code not depending on the connection. Now I said this is a tribute connection, and this was not what I planned to use. I will have to rewrite the code, which in its own right is going to take time. So I'm going to do more of explaining, and as I'm explaining, I'm going to use the code as an example, like this already existing code. Now, I need to explain what you guys are actually seeing in the first place in the code, so that even if I give you the code, it won't be confusing to you guys. So, first things first, you may be wondering, what is this? This is a library, right? In C++ code or any language, libraries are pre-written code that you can import into your own existing code, so help you with some functions, so that you won't have to be writing some functions over and over again every time you want to, right? You can just import the already existing library and just use the function from the library. So in this case, to be able to connect to our LCD, we're going to be using the Adafruit liquid crystal.h library that our very dear Tinkercad has provided for us. So now, in Tinkercad, this library is already included. You just have to import it. So now, first, another thing you have to do is know what this setup means. Okay, so first of all, what is the address? So the address is not used in this place box. It's here. So why I'm including the address, I think the reason I did not include the address in the default code, for anybody that is wondering, this from this to this is the default code from here to here. Here to here is the default code. I think let me increase the size of my screen. Okay. Let's see using the serial monitor. Can you all see it now? So this is the default code. So now the reason why I think they are not setting up an address like I did is because when I wrote the code, I wrote it in favor that, okay, we're going to be using more than one liquid crystal display. So since we're not going to be using more than one, we can just put it as 0 because it's only one that your address will be talking to. Now, how do you specify your address? In real life, like in a physical project, this address is always different for each LCD. And you should be able to check to know which address your particular LCD communicates on. So, but for Tinkercad, we're able to pick an address that we want. So this is the default address. So now, if you're having multiple LCDs, you connect with different addresses because they can't all talk on the same address. So let's say this one is going to be on address 32, the other one 33, and other things like that. That is why the address is here. But since they are just default code is just working with just one address, so one on LCD, they didn't really need to specify multiple addresses. Any question on that?
No.
Okay, no questions there. So I'll move on to the next part of the code. That is the setup. So here they didn't really put too much, so I don't think this is the best way. Let me give you this. Okay. So for everybody that remember, serial.begin initiates the serial monitor. But He did not use the serial monitor, that's why he's not there. So to initialize our LCD, we'll use init. So that what that does is it wakes up the LCD and prepares for it. So you must only use this. So you must use this only once in setup. You cannot put it more than once. Then next setup command is backlight. So what this does is it turns on the LCD backlight so you can see the display. I think they also use that here. Okay, so they didn't call it, so they just started the LCD, but what they did, they called it right here. So they called it in the function, in their loop function. So you can call it in loop function, you can call it in your initialization as in your setup. So then what they did again is LCD.clear. What I did again was LCD.clear. So what that does is it erases everything on the screen. So you use this when you want to start afresh. Let's say maybe there will be something on the screen, but let's say you want to start with new memory or things like that. So what that does is it erases everything on the screen. So now the next command is lcd.setCursor, the row and column. So what that does is I can't run the code because it's not going to run because of my extra code that's here. But if you remember then, it's so 16 columns, 2 rows. 0, 0 means start from row 0, column 0. You understand? So, and if you would have been wondering, isn't it 1 to 16? No, numbers start from 0. So start from 0, goes all the way to 15. Same with the row. Start from 0, it goes all the way to 1. So, for example, now the top left corner, this first one, this place will be 0, 0, 5 for top left corner. Let's say yes, bottom left corner is going to be 0, 1. For the top right, it's going to be 15, 0, and for the bottom right, it's going to be 15, 1. If you understand. Do you understand that? Okay. Let's check the chat if there's any question. Okay. So Israel asked how is mine displaying hello world and this one isn't. Well, it's going to be as a result of your code. As I said, when you get the connection correctly, everything is dependent on the code. But if the code is correct and it's not working, that means your connection is wrong somewhere. So if you have time, you can just crop a picture of your connection or you send your code to the group chat and I'll look at it. You also asked if did I get the existing code from Tinkercad libraries? Yes, but not the way you think it is. So the existing code that was there that ran the hello world came with this preview one I got. So let me show you. So when you want to build a new circuit, you pick what you want, right? So what I did was because we're running out of time, I picked a preview one, dragged this here. So I picked a preview one that was already set up and everything like that, and just came here. It's usually in blocks, but blocks is not the best thing to actually use with a project because it's just like doing scratch for all standard scratch. So change it from blocks and just change it to text and everything and led us to this place. This is not the original code that came with it. No, I changed it. Okay, back to the explanation. Any other questions? Any other questions? Okay. So I take it as 0 questions. So now in continuation, of what I was explaining before. So let me trace this code again so you guys can see code. Okay. So okay, we discussed about color. Then print. Print does exactly what it says. It just prints to the screen. So it writes text at the current place your cursor is. So just print to the screen. So and you can print variables, numbers, and strings. So these are all you're limited to printing variables, numbers, and strings. So now, one thing you should know is LCDs doesn't auto clear. So what it means is after you are done, you want to put anything to the screen, you have to clear every single time. If you get. Okay. So another thing you should do is another thing you should know is if your cursor is wrong, like your starting cursor is wrong, you are trying to print long sort of text is longer than your starting cursor, you might find out that depending on the kind of code you wrote or depending on the mood of the LCD or the type of LCD or just generally the mood, that either part of the text or just start showing gibberish. I've had experiences of both part of text start showing gibberish. So depending on the mood of the LCD at that period of time for the Arduino. So that's another thing to know. So another thing is professional ways to writing code, Arduino code, C++ code for Arduino and embedded system, actually for the LCD, and there's the amateur ways. This example that I have here is sort of like the non-professional way because so for example now, if I was to write a code or to print something now, and I want to like just make it use formatting to use file and other thing like that. What I'll do is I'm not saying you should use it. I'm just giving an example of the way I was going to write it. I was writing for a project. I'll create specify a character. I explained what a child is. I think did I? Yes, I think I explained that. Someone asked a question relating to it. So I talked about it a little in our last class. So for 7. So what is then I'll just use sprint f for this thing just space this 60 and distance then this LCD sets course your so parentheses then this then just LCD of kid. So for those that might be confused, this code doesn't really do much. What it just does is just anytime I run project, it's going to align anything that I'm running, it's going to align it. In our case, distance, it's going to align it 6 characters going to make align it to the right. You know, when you've let's see what that's closing. That's closed. I'm going to reopen it. Sorry about that. I forgot about this type. But what it means is when sorry. Okay, so what it means is when so what it means is on a system, when let's say you're writing something now, you can write from this position of the screen for those that can see my mouse. So you can write from this position. Let me let's okay, you guys should check the chart. Okay, now so for a normal day when you're writing, you get left aligned. That's you get aligned to the left. But if I want to, let's say I want to write from the right, so something like this. It's not showing very well here. I mean, I'm thinking of a way I can show it. So I'm sorry I'm diverting. I just want to explain what it means so that you guys won't be confused what's actually happened there. So, someone. So trying to like just change it, but this is not working. So maybe tomorrow then. So let's just go to continue. The network is a little bit funky here. Oh. So in the meantime, okay, so in the meantime, while that is loading, so let me show you what I meant about this. Side, start from the left. But for what I did there without set off and everything, what it means is anytime you type, it's a way to start from the left to right here. So use some space and start from the right. That's it. It's very end in this kind of place, if you understand what I mean. So why that is also loading because it does not loaded yet. Let me do this. So this what I had planned for the class. So the original design I had in mind for us to do was the LCD screen, which is ICS2 screen, and our HC, which is the ultrasonic sensor we talked about yesterday. The connections to see. Is able to make it finer. So there's no way to make it finer, but it's just 5 minutes. So in this 5 minutes, I want to explain the assignment I want to give you what it actually entails. So LCD ultrasonic distance meter, this is the diagram of the circuit. You can't really understand it because it's not looking fine. So what you do is for our LCD, I mentioned about the connection data. You connect the ground to ground VCC, which is a power connector, to the 5-volt connector, the SDA to the A4 and SCL to the A5. I mentioned that. Then for the HC, that's our distance sensor, ultrasonic distance sensor that I talked about last class. If you all remember, you know that trig and echo. Trig is for sending out signals, echo is to receive signals. So set this to any of the digital pins, 12, 13 in our case here. So on our breadboard, we set power pins. And they set the digital connections 12, 13 connected to power pins, which is power pins on the breadboard and other things like that. Same with the analog, the voltage sensor. So what you do is, let's look at some of this. Okay, yes. You place the LCD on the left side of the breadboard, which is the affect what you're building. Then you place the sensor on the right side of the breadboard. So for those that like connecting directly to the breadboard instead of connecting wires to the kidney, what you do is you connect both power rails. So the power rails on the top. Let's see it's loaded. Okay, that's loaded. So let me change. It might be it's just network that's making me read this way. So let's see what it is. Just see my entire screen, so I'll be able to switch between both. Okay, so you all can see my screen, right? So Now, now what I was explaining is for people that use the breadboard. Let's get a breadboard out here. So I know people that don't like using the breadboard. They disdain it, but for those that like using the breadboard, these are the power rails. You know what the power rails are? This. You connect your power rails together as this and this and this connected together. When you've done that, you run the SD and SCL line, the wires from the LCD to the A4, A5 connection pin. So you say you get. So this is not running through the analog form because this is just printing specific inputs rather than getting. Get what I'm trying to say, Sha. So you run this to this place, then you run this to this place. Then when you do that, you do the same thing for your ultrasonic sensor. This is the ultrasonic sensor we talked about last week. Sorry. So, okay. So this is the sensor we talked about last week, if you all can remember. So VCC goes to power. That's our 5 volts, 5 volt line. Then same. So what I was trying to explain earlier is that for those that want to use the breadboard, I mentioned about putting put this fine boy on the left. So no, I think it's going to be on the right because of the way the power pins are connected. You put this fine boy on the right, then take this fine boy right here, which is our sensor, put that on the left. So it's going to be easy for you to wire them doing any other wiring that you want to connect in the long run. Is that clear? So any questions, please? Any questions from this? Sure. Okay. So any questions? Because we've reached the end of our class for today. We'll continue tomorrow. We'll do it practical tomorrow. Any questions, please? Shall I ask question? So I can also ask question. Maybe the winner might get prize. We don't know. We don't know. Okay. Is there the question, please?
I'm still confused on how to accept it. I don't know what exactly you so you can come again.
I can't really hear your question. I don't know if it's my network or please. Does anybody that hear the question? Can you repeat or?
No, I didn't really hear it. I think his background is noisy. Israel, if you can type, I think that will help us a lot. So please can you type it out?
Okay, the assignment. So the assignment, what the assignment is going to be is the ultrasonic sensor that I just showed you now, and the sensor, that's the LCD sensor that we showed you. So your job is connecting both of it to the Arduino. So when you connect it, I'll give you the code to run so that you don't stress yourself writing code. I'll give you the code to run. Now you paste your code in your Tinkercad. And
but
if
then I think it would be better to let them write the code, because how are you going to master something you not practice it enough? And then if you now give them just like that, like I don't know,
So-
Sha, I'm just saying like my own personal opinion, but I think you should figure it out.
yes, I understand what you're trying to say, but the code is going to be a little bit complicated and overwhelming for them at first, especially for a first class or second class or something like that. So I'm going to give them the code. In the next assignment, I'm going to give them tomorrow. In the next assignment, I'm going to give them tomorrow. It's going to be 2. I'm just letting you know now. It's going to be 2. And there's prize for the person that does it best. So it's going to be 2 assignments. This first one, I'll give you the code, you run it. So that's to make sure that, okay, you're able to replicate what we did in class. Or we're going to do it tomorrow. So now, if I give you the code and you place it in your Tinker card and your LCD does not work, you should know that, oh, this my connection is wrong. So because if I don't give them the code, the problem might either be with their connection or with the code. Either of them might make the LCD not work. But if I give you the correct code and your LCD does not work, you should know that, oh, I've missed the connection, I cannot listen in class. But if it works, it means that, oh, I listen in class. So the one I will not give them tomorrow, because this one is very easy, something that they can complete within a few minutes, an hour at best. The one I'll give you tomorrow won't have code along with it. I'll just give you problem statements. Then you let me build my Arduino, my complete circuit, and my code. The winner will collect 5K from my hand. If the price is too small, me I increase them. So the winner will collect price from my hand. So for today's question, I don't know if I should throw in a question. Does anybody that answer this question correctly will collect 2K? Me and money down, because this one is like this is not really anything. So should I throw my question out, or someone will just like say, oh, let me answer this question, so volunteer myself to answer the question? Which how should we go about? How should we do it? So seems like everybody just wants to throw my question all about. Okay, so question can I give? What question can I give that won't be too simple for my 2K? Okay, so now, if you remember, I mentioned 2 addresses that we can use when we're connecting the LCD, not the ones I showed you on Tinkercad. When I was explaining, I mentioned 2 specific addresses. Does anyone remember those addresses? You can type it out, you can say it. The first person to answer wins my 2K. Anyone? It's looking like nobody wants 2K. Or should I increase the price money? Since like 2K is not changing you people. It's going. You know,
So nobody wants to answer. Yeah. Wow.
Mr. Daniel is trying to guess his way into the answer. Not pin number, address. So if let me even give you guys it. So it's I think it was I said 0x something and 0x something. So that's just the hint I can give you. So think of something I mentioned in relation to that. Start thinking. Who's the first person that we answer? Who's the first person that we answer? The money is going here. That's the first one. The second one, I mentioned 2. Mr. Daniel. I think I need to play all those high intense music to sort of create that ginger. Yeah, Ahmad. Does anybody want to help Mr. Daniel to share the price? Yeah. So at least you remember something. I will send you. Just drop your account number. Drop your account number on the group chat. No, it's not X0X20. It's 0x27 and 0x3f. 0x3f. So that's the second address mentioned. So, Mr. Daniel, please can you drop your account number before I leave so I won't forget? So, with that, come to the end of today's class. Tomorrow's class is going to be, see your princess, will it be long? Will it be the same 2 hours or still going to be 1 hour? So I'll know where to plan.
It will be 2 hours. I just wanted to make it 1 hour today because of You know,
Valentine.
it's the weekend. Yeah, on Valentine also.
Hey, I'm feeling the energy in the air.
Don't Sha, you can think whatever you want to think. But I was like, it's it's holiday, but it's not holiday. So I was like, let's just make it 1 hour.
Okay,
Let's just make it 1 hour.
all right then. So, Mr. Daniel, look the same thing your money right now. Network is still doing the station. So, searching for your name. Okay, let's see if the name is correct. I'm seeing Esther Olajumoke. Is that correct? Spirit thumbs up is correct. Okay. So, uh, yes. So, for tomorrow, you guys should. I'm going to send a code very soon. Just give me 15, 30 minutes to just settle down. I have another meeting. So, I'll send you. You should have received it, Mr. Daniel. Thank you for at least trying to answer my question. And also, this would be a regular occurrence. If you can answer my question correctly, you get your prize. And as I said earlier, saying that those that are selling the best or gives the best solution is also get a prize. So I'm someone that like to change my students. And it just looks like say it was small. You're doing 2K, 5K. Sometimes Holy Spirit can just touch human beings' hearts and pocket, just increase it to 20K, 10K, 50K one day. God bless all of us. And happy Valentine, even though you guys did not invite me to come and share the gifts and the red balloon that kept seeing around and everything. Can you see your princess? We saw the red, but we won't see anything. So we just have to like just look and pass.
Wait, what?
Nothing. I only said I saw the red.
You saw the ring?
Yes, I saw the red.
Okay, no problem.
So everybody have a good night. And Mr. Daniel, help me greet down Miss yours. We'll see you tomorrow, same time. Bye.
Thank you, everybody. Thank you, Afolabi. Good night, everybody. See you same time tomorrow, 6 p.m.